Well, it's been about 5 days now. I've had to wait for this capacitor to arrive. It's now arrived, and with a bit of luck it will fix this power supply. Try substituting it in place and we'll see what happens. Okay, so the capacitor is going in here at this location, and on the other side of the board they've conveniently marked the negative as a small black, just about to see it there, the small black mark, just like the others. So we're going to pop this one in. Not a great fit. I think I might just tweak the legs a little bit to make it fit a little better in there. It's sort of hard up against the edge of the transformer there. I think it's a little bit bigger than the original one, which is quite common. Okay, so I've bent the legs over to avoid the edge of the transformer, and let's see if that fits better now. That's much better there. A little bit of clearance from the transformer. Not ideal. If I was being particularly fussy, I'd probably put some hot glue there just to keep them apart. I may well do that anyway, assuming it works. So let's solder that in and give it a go. So, a nice clean iron. Tin the tip, and we'll just heat that joint up. You can see the slight sheen that lead-free solder tends to get when it cools there. A little bit blobby, that one. That's better. Let's reheat that one. I don't like the slightly sort of glazed look that they get. That's nicer. Okay, let's trim those legs and we'll see if it works. If I can find any snips. Oh, they were up here. Once upon a time when I had tools. Aha! Right, it's my weird little multi-snips. Let's just get in there and trim that one first. And I like to trim them nice and flush. There we go. Now, I did spot earlier in the video that there was a couple of little blobs of solder which I want to get rid of, if I can find them, or if they're still present. There they are. All gone. That's from when the rectifier was reflowed. Should always check for that sort of thing. Not sure what that is. Just a bit of flux. Doesn't do anyone any harm really. And if we can clean that off the board when we're done anyway with a bit of isopropyl alcohol, assuming it works. Let's try it. So first of all, just clearing the desk to make sure there's no little bits of metal. And maybe I'll zoom out just a smidge. Okay, so with the other end of this mains lead disconnected, I'm going to carefully insert the plug. We'll turn this the other way around to make life easier for the cabling. Now, in order to stop this from dancing about on the desk, because this mains lead is horribly twisted. This was wrapped up by somebody who believes in twisting cables around themselves to store them. It really doesn't do them any good. So I'm just going to trap it in the end of my table so it can't suddenly be torn off the table and out of my hands and zap me. Now let's locate the rest of the equipment. So here is the unit. It's the main condenser fan unit there, and here is the switch gear, which I'm going to keep off camera for now, and the base. It doesn't fit very well under the camera, I'm afraid, but so be it. If I turn the fan unit on its back, we can see if the fan spins. This connector is for the Peltier, and at the moment is completely unused. So it's going to plug in the low voltage side. Let's put this a little better in the shot. Doesn't really want to come. Yeah, that'll do. Right, now we should be able to plug this in at this point very carefully, noting that all of this will be live and potentially anything plugged into it as well. That includes the low voltage side if something's gone wrong. So let's plug it in. Now the LED looks much brighter on the power supply and the fan is spinning. Let's see if it's capable of driving the Peltier device as well. The fan bearings are extremely grotty, but it does its job, and it's not really anywhere that anyone's listening to it, so it just gets a spot of oil every now and again, and one day will seize up completely. Let's plug in the Peltier device, which connects this little header here, and let's just plug this little wire in. Okay, I'll have to leave that there. So, has it got enough oomph at this point to drive both the fan and the Peltier? Let's find out. Plug the mains back in. And it's got a dim LED again and appears to be unable to start up. Give the fan a little spin. Oh dear. So, perhaps there's nothing wrong with the power supply at this point. Is the Peltier simply putting out, drawing way too much current? This unit did get frozen, so let's just turn it off because it's annoying with the whining noise. So this unit did get left outside and it froze during the winter. It doesn't usually do that. It's been running for several years now, and this is the first time that's happened. So possibly the Peltier element is damaged. It's time to measure some voltages and see if this power supply is actually producing 12 volts now, or whether the problem lies elsewhere. Maybe hook the whole unit up to my bench power supply, which I can then measure the current that it's drawing and see if it's faulty in its own right. So I will do that now. I've got my ancient and slightly idiosyncratic multimeter just sat there, and that's on the 20 volt scale. I'm going to measure the voltage across these two terminals here, which are the supply to the Peltier effect device. I'm just going to plug it in, and noting that it's all going to be live again, I've also placed the lid of the power supply here, just to give a little bit of isolation from that if anything moves. So let's, without further ado, okay, so we've got the fan running. What voltage are we actually seeing across the terminals? And once again, it's just 10 volts. So something is still not right with this power. Right, so had a little bit of an inspect of the board, and there's not much to see. However, I have found a, let's just disconnect this power connector. So if we zoom down a little bit, I believe you can just about see that on camera. There's a solder joint which is located just here, and you can see there's a sort of a sheen to it. That's clearly a dry solder joint. I'm going to just reflow that one. I doubt that it's going to make any practical difference to this because it's only the discharge resistor for the main input capacitor. But I may reflow the pin neighbouring it as well. It doesn't look the greatest, and see if it makes any difference. I don't expect it will. Right, let's just apply a little solder here. Reflow that joint, and I'm also going to reflow this one next to it because it looks iffy. A bit too much solder. It's not going to hurt though. Okay, let's see if that makes any difference at all. Let's bring in the mains. Horrible connector at this end of the board, which really has to be held still to avoid damage to the board. It's really designed to be held by the casing. Okay, let's zoom out a little, and I shall try powering it up again. Well, the fan sounds better, that's probably coincidence. Right, what voltage are we seeing on the output? Shall just bring in my multimeter, set it to the 20 volt DC scale. And let's just measure the output. Still just 11 volts. Not great. Okay, back to the drawing board. It doesn't even produce that offload. It's not doing anything. Okay, let's try swapping the fan and the Peltier around and see if it's the fan that's causing the voltage rails to be dragged down. Because it is actually producing 12 volts when it's only running its own little internal LED. Interesting. Let's find out. Okay, so that's 12.35 volts. Oh, the light is reflecting horribly off that. 12.35 volts with the output just lighting the LED in the power supply. If I turn on the unit again, let's see what happens to that voltage. I can't hear it chirping, which is interesting. Go around. 2.7 volts. Well, clearly that's loading it down rather a lot, but it isn't actually preventing it from running altogether. At least not in the same way it was before. Still, clearly something is wrong. Let's turn it back off again. It should have bounced back up to bad contact there, I think. Why can I not get a reading of that? There we go. Poor contact. So, yeah, 12.35 volts offload. So there's nothing really wrong with the regulation on this power supply. Something is simply just not supplying enough power. I wonder what. Okay, I thought I'd mention this little trick which I've picked up for testing MOSFETs. I mean, usually they're quite obviously blown up, but I thought I may as well have some fun with this one while we've got it here. So this is the gate, the drain, and the source. Now, if you just start by shorting out the terminals. So if we measure now between the drain and the source with diode check mode, you can see it's open circuit. And in reverse, I think this one has a built-in diode, so there should be something, yeah, about 1 diode drop. So in order to test this, if you place the negative probe on the source and you place the positive on the gate briefly, that'll charge up the gate. And now, if I measure between the drain and the source, you can see, there we go, it's conducting. And if I just touch the pins, which will discharge the gate, it's gone back to non-conducting. So this one appears to be working. It doesn't really say anything for how well, but it hasn't got a hole in it. I'm going to put it back in the power supply. In the meantime, I've discovered that what the capacitors on the output side, one of which I removed, maybe I shouldn't have done, so I'm going to attempt to put a replacement in and see if anything improves. There's also a bit of a break I've discovered in the insulation of the positive cable coming out of the supply, which I shall have to address, but one thing at a time. So first things first, I'm just going to drop this capacitor in to replace one of the 3 that I removed originally. The issue here is that this one actually comes just after a inductor that I hadn't noticed, and as such it might actually make a difference if we replace it. I had thought all 3 capacitors were in parallel, but it turns out this is not the case. Soldering at such a shallow angle isn't the easiest thing. That's a bit better. Just get rid of some of the excess there. A little bit of flux. That's better. Okay, I'm going to leave those legs untrimmed for now, as I don't know whether we're going to even bother replacing this or not. There's no point in throwing away good components, so let's put the MOSFET back in. The holes line up, but the pins are too dirty to go through. So let's just clean them off. Probably good enough to get them through the holes. The 4th pin on the heatsink should be fine as well. There we go. So just tack one of the pins on now, so that the whole thing can be aligned properly. Clean this soldering out it. Okay, let's just tack on. Come on, float. Something wrong with this soldering iron. I think it doesn't flow solder as well as it used to. I wonder if there's some issue with the heater. Right. That's nicely lined up. Let's solder them properly. Also working at the very limit of the cable here on my desk, so it's making it very awkward to solder some of these pins. Okay, let's reflow this one. In case anyone's wondering, it's not just that the temperature's set too low, because quite honestly it isn't. But thermal contact here somewhere is not good enough. Oopsie, didn't really want to do that one. Come the other side. Come on. There we go. And then the big one over here. One of the problems with temperature controlled soldering irons is that the actual temperature control can compensate for quite a lot of failing in the iron itself, but it's very slow to do so, which is what we're seeing here. You can see as soon as it thinks it's got warm, there's just no more power. This pad should not be so difficult to solder with a 60-watt iron. There it goes, it's warming up a bit. Horrible fluxless rubbish up there. Go away. There we go. I'm going to zoom in for you. Oops a daisy, where did the solder go? There was a blob there and it's gone. Must have knocked it out of the way altogether. So, can we refocus that a little? That's a bit better. So there's the pin that holds the heatsink on, and there are the 3 pins on the MOSFET. I've seen better looking joints, but as I said, the iron's not behaving very well today. Right, let's see if that works any better with the filtering put right on the output. So, coming back to this, it's a little puzzling. I think I found something of interest here. You may notice at the back of the board here, I've got 2 components lifted off. That's because there's a track there. Now, it turns out I was completely wrong about all of this. This isn't feedback. This isn't the power supply for the little control chip here. It turns out these 2 resistors here are the power supply for this chip, and there's a diode, which is, I think, this pair of pins here, and the capacitor is here. This is the capacitor I resoldered earlier. However, the 2 feedback winding pins are here and here. This one goes to the diode, and this one goes to the capacitor, the positive leg. And from there, as far as I can tell, it goes absolutely nowhere, which is a bit odd. It's not much use, at least, anyway. My apologies, that's the negative leg, and this is the positive going side there through the diode. So I was expecting this to connect back to the chip, and it seems like it should. There appears to be a trace that goes under these 2 components to this point here, which is actually a sort of a star ground almost. This is the notional ground here. This is the Briggs rectifier. So yeah, this should be ground, and so should that, if what I'm seeing on the board is correct. But if I take my probes, I can place one on, say, this pin here, and one on this pin, and there's continuity. But I cannot get continuity to here, or indeed pretty much anywhere else. So what's going on? I think I'm going to clean this here and see if I can find out what's supposed to be there, because it looks like there should be a trace. Let me zoom in. And I think you can see there. So there's the pin of the capacitor, which I believe should be connected to a trace going underneath these two components. And it seems rather odd that they would have placed a 0 ohm link here if there was nothing to jump over. It's usually used as a bridge on these single layer boards. So I'm going to investigate that more thoroughly and see if we haven't just found the fault here. And I'm back. Be right back. I've brought a little container of acetone upstairs, which I'm hoping will dissolve the glue that has been used on the circuit board. Isopropyl alcohol would probably not be a good choice because they probably wash the boards with that anyway, if they bother at all. I need to get a little dribble on there. Stinky stuff. Okay, so let's just try and remove this glue that was used to assemble things in the factory. Well, there's definitely a trace under there. Where does it go? Well, there's a distinct break in the trace there. One does wonder, has this power supply been simply missing its... Aha, I see what's gone wrong here. And I'm afraid it's my fault. So what's happened here is that... I shall zoom down. So, you can probably see it now. There is a small break in the trace there. That was probably caused by me being a little bit overly violent with this pad when I removed the capacitor. Not quite sure how that happened, but I did notice when I put it back in that I had to straighten the pad, but I didn't realise that it had a trace coming off this way. So the whole circuit has been operating without any power supply from its feedback winding. So probably all the power that it's been producing has been just from the initial startup, from this little chip trying to start up and just giving up. Well, let's try and bridge that and see if it works. Okay, so that's focused on down. Now, first things first, let's just deal with the... First things first, let's just deal with the track here that's exposed. I'm going to just apply a little solder to that. Not too much. But I think port capacitor's going to get a bit warm there otherwise. Okay, where's my bodge wire? Is it escaped over here? I'm going to tin my bodge wire. Which I shall just do now. Get the solder to melt. bodge wire tinned, and let's just tack that onto there, and also onto the leg of the capacitor. Okay, that's there. Just wiggle that loose. Okay, I can't reuse the 0 ohm link there, so I shall have to use the bodge wire to route around that bit of damage there. But that's no biggie. Sit the Zener diode back down where it belongs now. I bet it doesn't want to. Okay, let's just convince it wants to go there now. Get over. Stay liquid. Okay, cheating time. Just disconnect the bridge between those two pads there. If it is indeed a bridge. It probably isn't anyway, so it doesn't really matter. That looks okay. I'll measure that in a moment. And that I could do with being a little snugger to the board there. There we go. That black smudge is just dirt. As you can see. Okay, let's test that and see if it's got continuity. Okay, let's measure between, say, there and there. Yes, that's bad. We don't want that. But we have continuity there again, which is good. Okay, so where's that shorting? Is it really? I think that's a little hard to believe. That's... Bugger. Let's try that again. Poor little Zener diode. Ah, of course. Sort of expecting that. Right. That's a nuisance. Was it actually meant to be connected to there? Possibly. Yes, it's this pin it shouldn't have been connected to. Right, okay. Back to poking it around again until it wants to go where I want it. Alright, some success. I took that away to resolder it separately because it was proving to be a bit too tricky without being able to reach anything properly. Plus my soldering iron's at the absolute limit of its cable at this point on my desk. So I've put a bodge wire in to replace the 0 ohm link. I've replaced the Xena diode, and now it behaves quite differently. Watch what happens when I plug it in. One moment. Now that is a power supply trying to start up. Until the capacitor goes flat. Right, so what's happening here? Well, the eagle-eyed amongst you may notice that I've been cheating on you all, and I've done a little bit of poking around off camera, including, in particular, I cut this track by way of diagnosing problems. I cut this track here by way of diagnosing the problem, and this is the feedback path. This is the opto isolator underneath here. So there's the low voltage side, there's the high voltage side. I'd forgotten that I'd done that. Presumably when it starts up, this chip is intelligent enough to realize that its feedback is missing, and it gives up. And so if I reconnect the feedback, perhaps this might actually work now. So let's do that. I'll attempt to do that here at the limit of my soldering iron's cable. And this is all unplugged again, just to make sure, yes. And we'll just bridge out that big capacitor again. That's there and there. Sorry, no, there and there. Probably pays to make sure you bridge out the right pins when you're bridging out those big capacitors. It never seems to have any charge after a few seconds anyway on this board. Right, so first things first, let's scrape away just a little bit of the insulation here. This is the solder resist on the bottom of the board, this green stuff. A little bit off center there by the look of it. Okay, so if I get my bit of bodge wire, rescue it from over here, and hopefully I can reach well enough to do this. Here's the solder. So let's tin the pads. Filthy soldering iron again. Really need to get a new tip for this thing. Come on. Can take a couple of goes to get this stuff to stick on these boards once you've removed the coating. Oops, a little blobby. I'm going to just pull this closer to me to do, because I can't scratch the board with the tip of the iron here, which typically works better than everything else. There we go. That's the tip of the iron scratching the board there to clean it, and now it should take solder. I hate this angle. Alright, let's get rid of that blob. Okay, blob dealt with, mostly. Alright, let's see about getting some solder on those two pads again. Melt. This is worse than my old Antec iron. There we go. Let's just tack on this little bridge. There we go. Beautiful. And then we'll just break that loose. There we go. feedback winding reconnected. So, was the problem in this all along something wrong with the power supply to the was the problem all along something to do with the power supply to the switching controlling chip? And if so, have we fixed it? Let's find out. I'll zoom back out and see the fan again. Bring that to the shot a bit. Okay, let's apply power. See if it all goes bang. Ooh. Well, that's running. Now, what happens if I plug in the Peltier device? Ooh, and it continues running. Well, I'm going to call that fixed. I think I may as well leave the small extra capacitor I put on the output in there. I don't see any point in removing it. I'm going to make all this clean and safe again, put it back in its box, and it can go back in the car for another year to keep it nice and dry. Excellent. Can we measure the voltage on the output while we're at it, just for some extra information? Just keeping in mind all this is live, I need to move my multimeter into the shot. So we're on the 20 volt range with the bonus additional decimal point. And here's the output. Let's get the right probe on which pin. So there is ground and 12.34 volts, spot on. Okay, so the problem in this was not actually the output capacitors, as is so often the case, but it was in fact the... I'm just going to turn that off because the fan is incredibly annoying. So the problem turns out to have actually been the little capacitor which provides the power supply for the switching controller. That would be, remembering this has just been on and it clearly still has some power in it because the LED is green, this capacitor down here. So let's clean it up and get it back into service. Excellent, another one fixed. Okay, so here's the unit sat back in the plastic housing it came in, and I'm going to try and glue the housing back together again. I don't know if it's going to work. If it doesn't, it'll just have some tape wrapped around it, but as I'm never going to be giving this to anybody to use other than myself, I don't really consider that to be much of a problem. So here goes. And this is the end result. It doesn't look pretty. The glue claims it works on ABS, and I assume this is made of ABS, but we'll see if it actually sticks together. For now, I'm just going to leave it wrapped in tape so the glue's got some time to do its job. And I'm going to go and put this back in service. And although there's a fair bit of noise there, I'll just turn these off for a moment. This is where it lives. It just sits in my car collecting any moisture that gets in, and at some point I'll get around to actually doing something with this car, but until then at least it's dry. I'll have to do something about that fan at some point, but for now I shall just leave this doing its thing.